Good afternoon, everyone. Thank you all for coming. My name is Rosemary Bundock, and I am the Event and Program Coordinator here at Bridging Nations Foundation. Thank you for coming to our seminar on Big Data and Student Employability. So I just wanted to give a brief introduction on Bridging Nations. Some of you are new faces and some are old friends. So this will be a very, very quick, brief introduction. As depicted here, Bridging Nations is a nonprofit organization with offices both in Washington, D.C. and Pune, India. Dr. Ambagankar, our CEO, founded the organization back in 2002. And as in this image, you can see that Bridging Nations was founded on the basis of bridging and connecting global leadership with technological innovations to create shared global prosperity. One of the first initiatives for the Bridging Nations Foundation is the Prosperity Triangle. As you can see here, the triangle which connects US, India, China is dedicated to creating for the space of three economies to practice global leadership and economic cooperation. Second initiative, which is more on our forefront as of lately, is the Higher Education Triangle, which connects academics, government, and industry. Last year we hosted the Higher Education Tsunami Winners and Losers Conference, which was focused on broader issues in higher education, but as of now we are shifting our focus solely on post-secondary student employability and student jobs, the topic of our seminar today. So before we start with the program, I just want to invite you all to a reception that we will be having after at 5 p.m. in our office suite, number 715. And now at this time, I would like to turn it over to Dr. Ambagankar, who will introduce the two speakers for today's event and talk more about big data. Thank you.
Thank you all for coming, and I'm very delighted, and thank you, Rosemary, for organizing this event. The topic, I think you are here because it is very close to your heart. And I must say we're very, very fortunate on this complicated topic. We have two great speakers. You have their full bios, but I want to give a little personal touch of when I got to meet them and talk to them and discuss with them. Our first speaker, Dr. Vai, is from IBM. He is heading up the global big data platform and how to make it known to entrepreneurs and rest of the more or less innovative people. That is how I got to meet him in one conference in California and Strata Group. And I was so impressed with some of the things that he has been doing, and he has been very kind to come from Boston in such a not so good weather. But I guess it's probably equally bad in Boston too, right? But thank you very much. And Dr. Kirk, he is our local person from George Mason University. And what you will find, and when you see his presentation, is the width and the depth of his experience in this subject. And I was completely shocked when I talked to him, discussed with him, and saw the research and the work that he has done, from taking the most challenging problems in the NASA and now bringing it into the real life situations. And he created the data science program at George Mason University. So I want to welcome both of them. And after they make the presentations, I will take about 5-10 minutes what Bridging Nations is doing in this subject and why this topic for the day. Thank you again. And if it was not for you, all of us will be disappointed. But I think this is fantastic. I know most of you, but quite a few of you are new. And welcome to Bridging Nations conference seminar. Thank you. Great, the first. Rosemary, do you want him to use it or you will change it there? So do you want him to switch?
Yes. Sorry. Apologies.
Okay. then I think, Dr. Bai, you can.
Yeah, my apologies.
Just push this one.
Yep, you can press any button. And here's the microphone.
So, okay.
It's an honor to be here to talk about big data. So actually, when I left Boston this morning, it was sunny there. So, but I love DC. Even the weather is lousy, it's still a nice city. Okay. So my focus today is to talk about what heck is going on in the world of big data. Okay. So my focus at IBM is to develop a partner ecosystem for big data platforms. Okay. That's my focus. And what is big data? That's my first topic. And if you put the 5 CIOs in the room, they may have different definition of what big data is. So it's not, we do have a really agreed upon definition for big data. But if you look at the challenges we are facing, okay, regarding big data, they have some common characteristics. Okay, so big data to begin with is all data. Okay, that's first thing we notice. Okay, and it has to do with 4 V's. Okay? People are talking about 4 V's about big data. Number 1 is volume. Right, we have a lot of data, and that's the first characteristic. Number 2 is variety. It's not only we have more data, we have a lot of data, but we have different kinds of data. Right? We have structured data, unstructured data, and semi-structured data. Right? So that's the second characteristic of big data. Right? It's not only big, but also it has variety. Okay? Now the third V is velocity. Okay? It's not only data at rest. Okay, you have a lot of data, you have a lot of variety of data, but also data is moving. Okay, it's moving very fast, right? Like if you look at sensor data, look at social media data, you look at video, audio. All this data is in motion, right? So that's the velocity part. Okay, it's not just a lot of data, a lot of kinds of data, but data is moving very fast. The last V has to do with variety, right? Veracity, I'm sorry. Okay, data is also uncertain. Okay, if you poll a lot of CEOs, they say, "I don't trust the data we have. Okay? Maybe only 50% of data I have confidence in." Right? That's another challenge big data can help address, is to figure out the way to verify. Okay, the truthfulness of data you have. So that's the 4 V's. So again, we do have a definition of big data, okay, but these are the common traits we are trying to figure out how to address. That's big data. Okay. There are some very practical definitions of big data, right? One version I like a little bit because it's easy to relate to is to capture and use more data for more daily activities. Okay, this is very simple, not very sophisticated, but it captures the essence of big data, right? You have more and more data, you have to figure out a way to capture it, right? So data is everywhere. How to capture data is one challenge. And how to use the data, how to turn the data into insights, okay? Turn insights into action. Okay? That's what big data is about, okay? Therefore, data use is not a theory. Right? It's not something abstract. You want to do this in real life to improve our daily life. Okay? That's the ultimate purpose. And today's topic is about student employment. Right? That's one very common problem we want to solve. Right? That's a good use case for big data. And we talk about data everywhere. A lot of data. Right? These are examples of the kinds of data big data technology helps to deal with, right? You have transactional and application data, right? That has to do with volume. This is structured data, okay? Then you have machine data, a lot of logs, okay? That's a type of machine data, right? Sensor data, okay? Then we have social data, Facebook, Twitter, okay? And Tumblr, and so on. And it has a lot of variety. It tends to be structured. unstructured, I'm sorry. Okay. And then you have a lot of enterprise data, right? Enterprise content data. So a lot of texts, and talk about resumes. And those are the types of data big data can help really make sense of it. I will go quickly, right? So for big data, what is the difference between big data and the traditional approach? Right? And there's a paradigm shift here, right? The traditional way of doing things, of dealing with data is still very much relevant, right? So you have data warehouse, database, relational database, and so on and so forth. Those technologies are not obsolete, but they are still very useful. Okay? But you will see a paradigm shift, right? The difference between big data and this traditional approach is very telling. Okay? For example, right? If you talk about the old approach, right? So you analyze a subset of the data available, right? So for big data, you analyze all available data, right? That's one paradigm shift. Okay? The second one is to really, the old approach, you first analyze a small amount of very organized information, right? Relational database, right? Structured data. Okay? Then you do that before any analysis. Right? But for big data, you will see that you have to reduce the effort required to leverage data, right? So you begin with whatever is there. Okay? So that's another paradigm shift. Okay? That is, you deal with data what it appears in its original format without any conversion, right? So all the approach, you have to convert data into certain format before you can analyze it. Right? Now you don't have to do that. Okay? You can analyze data in its original format. The last point is, I'm sorry, right here, is you can now leverage data as it is captured. Okay? There's no wait. It's real time. Okay? That's another paradigm shift. Okay, I will not go into every detail here, but the key difference between the traditional approach and the big data is that in the traditional approach, you have the organized data to help you run the business. Okay? With big data, you have the technology to help you change business. Okay? Maybe run business as opposed to change business. Okay? That's the big difference between what traditional approach does and what big data can help. Okay? And the second question is, why act now? Why is now the time to talk about big data or to deploy big data technology? Okay? And it first has to do with competition, right? If you want to outperform your competitors, you have to begin to deploy a big data technology. Okay? It can help you to manage risk, right? Because there's risk everywhere. But how do you manage that? Without big data, it's hard to do. Okay? And the third reason to act now is to really help make your IT operations more agile. Okay? So that's a third compelling reason to adopt a big data strategy. Okay? And so with big data, you can really leverage a lot of untapped resources you cannot or you could not do in the past. Okay? You can really empower everyone. You don't have to rely upon IT, okay, a DBA or data specialist to help you. Right? Everybody can be empowered to make business decisions because of big data. Right? Then you can increase value very quickly. Okay, and big data is a big market, right? So there are a lot of numbers out there, and according to IDC, one of the most reputable agencies, and the market opportunity for big data will be 220 billion by next year. Right? That's a lot of money out there. Right? That's why we want to get into this market as soon as possible. Okay? And there's a lot of analogies about big data. Some people say big data is oil, right? Because you have to refine, okay, the crude oil and to make gas and gasoline or petroleum, as they say in the UK. And they also compare big data to electricity, right? In the beginning, very few people knew how to leverage electricity, right? Some people were even scared of electricity, right? Now electricity is everywhere. I think big data is at a stage where people are still trepidant about it, right? What is big data? Why should I get into this big mess? Right? But it has a lot of potential. And also, big data is compared to gold, a gold mine. Right? But you have a lot of sand here, right? You have to find a way to find gold, the real gold. Okay, and that's why you need some technology to help. Okay. There are a lot of use cases for big data, right? These are just some examples. Right? We're talking about in various verticals, right? Like e-commerce, you can analyze internet behavior very easily with big data technology. Okay, and in health and life sciences, for example, right? We have adopt some technology to analyze, say, for example, prenatal, all the vital signs of babies in hospital. There are so many data points you can collect, and you can analyze that in real time, so that you can help either diagnosis or prevent any serious problems from occurring. Right? You can help in that regard. Right? In the telecom space, you can use the big data technology to analyze, for example, the customer data records. Right? There are thousands, millions of records you can process per second to get insights into customer behavior or customer intent to buy, to make your marketing campaign more effective. Right? So in government sector, right, for defense or cyber security, you can really leverage big data to improve, okay, situational awareness. You know what's going on in real time. So those are just some very simple use cases you can adopt in your daily life in various verticals, various industries. In terms of today's topic, right, how can we leverage big data? There are two things maybe you want to think about in terms of big data strategy. Right? Number one is to figure out what data sources you can leverage. Right? There are public data sources, right, social media and whatnot. Right? There are also proprietary data assets. So the first thing you want to look at is how to build or create proprietary data assets, or to create something around the social media data or public available data, and to create some unique collection of data, so that you can create a market niche. Right? Other people cannot compete with you. So that's maybe the first thing you want to think about. The other spectrum is that we have a lot of technologies. I will show some IBM technologies momentarily. But the thing is, what do you want to visualize? Okay, what kind of application you want to build, leveraging big data platforms? Right? People maybe talk about Hadoop, a NoSQL database. We have all these technologies out there. But you have to have a very clear idea what you want to achieve, right? What kind of insights you want to get before you can really build a meaningful big data practice. That's maybe where we are today, is to figure out how to create some use cases in this particular space. Right? But that's another thing, right? Back to that definition, a very practical definition of big data is how to capture and use more data for more daily activities, right? So that's what big data is all about, right? With big data, you can predict more and more accurately, right? So that's one big advantage of big data, because you analyze data as it is created, okay, in motion, okay, in its original format. So you can reach conclusions very, very quickly. And also with more data, it's not a subset of data, you can predict more accurately, right? So that's one thing big data does very well, is to predict what's going on. Okay? And the second maybe advantage of big data is to really create a data reservoir, right? I mentioned create more data assets. Okay? So the more data you have, the more accurate your decision making will be. And that's another part of the big data strategy. Okay? So eventually, what you want to achieve is to make more sense out of this messy life, okay? Because we have more data. Okay? So that's a common thread of all kinds of use cases regarding big data. So how am I doing with time? Okay? So there are three key imperatives for big data and analytics success, right? So you have to build a culture, okay, that enables you to analyze everything everywhere, right? So you have to have the imagination. Okay? That's the first step. You have to invest in big data and analytics platform, right? So again, we have platforms available for you to leverage. So you have to realize that potential. And the last one, you have to be proactive about various issues surrounding big data, like privacy, security, right? This is a big challenge, right? So because how much data can you access, can you use? Okay, that's a big issue, right? How about personal medical records, for example, right? How much you can capture and how much you can share with the public. So you have to make sure that you can trust the data you are using, or you are allowed by law to use data for your either commercial or other purposes. Okay? Okay, so I'm from IBM. I have to do some propaganda for IBM, right? So you have seen this coming, have you? Okay, so that's my last two slides. Okay, not too much commercials here. Okay, so IBM is has a very comprehensive big data platform, right? So we have actually established something called Watson Foundations. So everything related to big data or analytics is rebranded under this big umbrella called Watson Foundations by famous Jeopardy and whatnot, right? So that's we have invested billions of dollars into this platform. So we have several technologies which can be used. So the platform is there, right? Just give you a big data vision. This is the architecture of what big data can deliver, right? So you have all the data sources. You have the platform, and we have Hadoop, right? That's a very powerful, very popular platform. Then we have a real-time streaming computing platform. We have a data warehouse technology, and so that's a very powerful platform. Then you have all these applications and visualization tools. Okay? We can always invite or embrace other partners to help with those as well, okay? And this is a fast, quick look of the architecture. Okay? I think I'm good, right? Thank you.
Yeah. So thank you. I'll follow the tradition of not using the mic here. I was told that I should start with an exam, and I left the exam at home, so we'll just have to do it orally. Okay, so it's usually a multiple choice exam, so you can just raise your hand if you agree with the following statement, that big data is the new oil. You guys know what I mean with that? Okay. Big data is the new black. Big data is the new bacon. Big data is sexy. Or my favorite, big data is everything quantified and tracked. All right. So I know what you're thinking. You had me at bacon, right? So I come from across the river. I'm a professor at George Mason University. I've been there 11 years. Prior to that, I spent nearly 20 years at NASA. First in Baltimore, then in the Goddard Space Flight Center in Greenbelt, right around the Beltway from here. So many years in this region. So I went to George Mason because they had a graduate program in computational science and informatics, informatics being data science. So after 18 years supporting various NASA space science data projects, first with the Hubble Space Telescope, and then with the Astrophysics Data Facility in Greenbelt, I've had many years of working with large data sets and began to see more and more the value of discovery, of that data for discovery, and in fact new discovery, as the data sets grew larger and larger and larger. So the potential for discovery was accelerating enormously. And so I decided to move to the university to focus on data science, even though my background has always been astrophysics. So people say, oh, is this an astrophysics talk? No. So that's probably the last time you hear me say the word in the talk today. Maybe not, I don't know. So I went to George Mason because they had a graduate program in this field since 1991. Okay, so nearly a quarter of a century, long before anyone ever knew what data science was. So we call it informatics. So you're probably familiar with geoinformatics and bioinformatics. And now there's many, many more such disciplines. So informatics is essentially the application of data science to a discipline, as in bioinformatics, geoinformatics, astroinformatics, health informatics, and many more. And so in going there, I realized the importance of this content, this literacy, as we call it data literacy, this knowledge needs to be translated further down the education pipeline than just at the graduate level. And so I helped to create there a bachelor's degree in data science, where we accepted the first students in 2007, way before its time, right? I mean, so 2012 is when the world first heard a lot about big data. So in late March of 2012, the president announced the National Big Data Initiative. Okay, so March 31st, 2012 was a really big day for those of us who've been doing this for a long time. The president of the United States made it a national priority. Later in that year, there was an article written in the very prestigious Harvard Business Review with the title, Big Data, the Sexiest Job of the 21st Century. Okay, so that was yet another turning point in this field. Okay, so a very highly quoted article. Of course, the title didn't hurt. Okay, but for me, I found that really a good way of describing this field. Okay, so I'm going to come at this from a perspective both as a researcher and also as an educator. And why that title, Big Data is Sexy, is attractive to me is because it represents what big data and data science is to those out there who have yet to catch the bug, okay, the students of the younger generation. And that is, they see in this a very attractive field, job opportunity, exciting problems to be solved, really interesting challenges, interesting tools, interesting things to do. And so it's attracting the very best and the very brightest in this field. So I often tell people that that rings really true to me when I go to conferences, and I'm usually the grayest haired guy in the room, and some of the people giving talks at some of the big data conferences I go to, these people are like CTOs or CIOs or chief data officers for various corporations like Yelp and Bitly and Twitter and a whole bunch of other these social startup companies. And these people who are giving these talks, these CIOs and CTOs and CEOs, these people are younger than my children. So that's kind of scary for me, but nevertheless, it's confirming that big data is attracting the best and the brightest. Okay, so we know all about the big data flood. Thank you, Dr. Bai, for giving a lot of good introduction and then the sort of the deep things that IBM are doing. So I'm going to do a little bit an introduction myself and then go sort of deep in a different direction with you this afternoon. So you'll have two introductions and two sets of sort of deep views of this. And so I just want to mention on Twitter there that Twitter is one source of massive data in the world. Okay? So people who are on social media know this already. So things like Twitter, but other social media outlets they're actually measuring the pulse of the world. So when I get to my definition, which you've already heard, big data is everything quantified and tracked. This is an example of that. So now, social media from all across the globe, people are tweeting, updating Facebook status, Instagram, Pinterest, or wherever they post information, ideas, feelings, what's going on around them, what they're doing, where they are. All those things are measuring the social pulse of the world. So whether people are about to have an uprising in their country, or whether they're feeling the earth tremble and there's an earthquake happening, or something is going on, it's usually noted first in social media. So if you remember back when Osama bin Laden was found and taken out, one of the first, after the fact, they discovered that one of the first signals of that to the world was some guy in Pakistan there who was working late one night, heard these helicopters, and he tweeted about it. Gee, what, you know, like, I don't know what it was, 2 o'clock in the morning or something. There was some tweet that, gee, I'm hearing helicopters, kind of late at night to be hearing helicopters. Well, it turned out it was the American troops coming in. Okay, so even though that person didn't know what it was, there was a signal of the event already out there in the social media world. Okay, so Twitter produces about 500 million tweets per day, and that's just me, but it's a lot of data. Okay. So I put this up here, measuring data quantities, just as a reminder, not that that we need to educate you, but as a reminder that when we talk about these things, bytes, kilobytes, megabytes, gigabytes, terabytes, petabytes, exabytes, we sometimes just sort of get lost in the word, and we forget that each one of these things is a factor of 1,000 bigger than the one before it. So I do a little concept test with my students. I say, put these things in order and do sort of comparative things on exams. And what I sort of learned from doing that is that sort of conceptually in our minds, we're still stuck on the powers of 10 here. Okay, so you see the powers of 10 on 2 to the 10, 2 to the 20. And so students sort of think of that as a factor of 10. No, these are powers of 10, not factors of 10. Okay? Which means each one of these is 1,000 of the one before it. Okay, so an exabyte is 1,000 petabytes, it's 1,000,000 terabytes, it's 1,000,000,000 gigabytes, and it's 1,000,000,000,000 megabytes. So for those who were around in the early 80s with the home PC revolution, your first home computer probably had a megabyte of RAM or something like that if you were lucky. Okay, or it had a 640 kilobyte hard drive. Anyone remember this? I mean, Bill Gates said, right? He said he couldn't imagine anyone in the world needing more than 640 kilobytes. Okay. All right. Well, of course, people say crazy things, but anyway, that's okay. I say crazy things too. But the whole idea is that the volume is enormous, and this is what sort of makes big data so much different from what we've had before, and that is not only tracking the world in social dimensions and space and time and weather and business, government, everything else, we're tracking it in more finer detail, and as we just heard, in time resolution, so it's not just what happened yesterday is stored in my database, it's what's happening now and it's being updated constantly. And we're moving beyond the exabytes, the last one on the list before, to these new words that you might start hearing in the years ahead. These are all real, they're all another factor of 1,000 of the one before it. And in fact, there's something at 10 to the 30 bytes called geobytes. And if we ever get beyond that, at 10 to the 33 bytes, they call that the epic byte. And I think at that point, the world collapses in on its own data. So if you want to, so the black hole will be at the epic byte, I think. Okay. So this is an interesting little illustration. I just found this on the internet. It's called the CDC in Killington, England. And this community collected up their CDs that people were just throwing away and filling the landfill with. And they said, well, are we just going to fill the landfill and create all this eco-waste? They decided to make something pleasant out of it. And they put them all out in the field and created a little path through it. All right, so people can visit. And this is a huge field. And it's 600,000 CDs. All right? 600,000 CDs, if you were to store data to a capacity, it's about 0.5 gigabyte each. So that's about 300 terabytes. That's not even 1 petabyte. All right? So things like the Large Hadron Collider, the thing that found the Higgs boson, produces a petabyte a second. All right? So there's a big astronomy. Well, I mentioned the word astronomy. There's a big astronomy project coming in a few years. called the Square Kilometre Array, which is a joint project between South Africa and Australia. It's going to produce 5 exabytes, that's about 5,000 petabytes per day. All right, this is like nothing compared to that, okay? But it's something. And so the point of this is that big data is not just more data, it's something different. It's not just more of the same. It truly is different. Like I say, back in the day, a student would come to me, want to do a research project, and want some data, I hand them a CD. So now, I would give them data from the LSST project that I'm working on. Actually, it's not built yet, but when it is built, if I give them data from the LSST project, the amount of data that I would have to give that student would be CDs that filled the entire football stadium of an NFL stadium. Wall to wall, floor to ceiling. Hundreds of millions of CDs would represent that one experiment. All right, so I can't give that to my student and say, go analyze this and come back tomorrow with an answer, or come back any time in a million lifetimes with an answer. I mean, it's just no longer the same. It is really different. So this is part of my big data manifesto, is that big data is not just more of the same. Some people will say that. Some people say big data is just more of the same. It's not more of the same. It really is a completely different paradigm. And what we're trying to get from it is discovering things. Okay, we sometimes call that the unknown unknowns, finding the things we never expected to find. All right, so this phrase was initiated according to popular media by Donald Rumsfeld, but I can tell you the truth that Donald Rumsfeld heard it from me in a top secret meeting I had at the Executive Office of the President 1 month before he went public with this. All right, true story, okay? So we were talking about the unknown unknowns right at the very beginning of this data science revolution over a dozen years ago, right after 9/11, and even before then. So you can read my paper from 1999 where I talked about this, okay? So what we're doing is finding the things we never expected, like terrorists flying airplanes into buildings. Who expected that before? All right, so these types of unexpected behaviors, patterns, trends in people behavior, as well as scientific data or weather behavior or climate or whatever it is your field you're working in, this is what we're going after. This is why we're collecting all this data, to find new and amazing things. So we're trying to address this challenge of all this data to making these discoveries. So this data to knowledge challenge is taking that stadium full of CDs, if you will, and then actually learning from it, getting some knowledge from it, getting some information from it, so that we can move forward. All right, so you can't do this with a handful of people. We need a whole society working with data and information. And it doesn't mean everyone's going to sit there and be coding, Python or C or whatever your favorite package is. It's not that everyone's going to become a programmer. It's just that everyone has to be literate in the use of information, because we live in an information-rich world. Okay, so this information-rich world is ubiquitous. Every student that I know is aware of it already, even though they may not be aware of it. All right, because they sit in the back of the room, not criticizing anybody, but they're looking at their smartphone. Sorry. Just kidding. They're updating their Facebook status. Okay, they're tweeting. Hopefully you're tweeting about this talk right now. Okay, so yeah, so they're creating information and consuming information all the time. And so if we can learn from this information, we become a better world in terms of making better decisions. So this attractive nature of the sexy nature of data science, I think, personally, stems from this human characteristic that we love to explore. We love to ask questions. We want to know what the heck is going on. Right? Okay, so ever since the beginning of humanity, we've asked questions like, what's out there? What is it? Why are we here? What are all these things? Okay, and children do this all the time. So I have grandchildren now. I watch this happen. They pick things up and put it in their mouth. They're testing. Besides testing their parents and grandparents, they're testing. Okay, so we are born experimenters. We're born scientists. Okay, so we ask questions. And what happens when you ask questions is you eventually come up with more questions, because you're not completely satisfied with the answers you find, right? And of course, in science, what that means is we do another experiment to collect more data, and on it goes. And then it's the snowball effect. And here we end up with these experiments that produce a petabyte a second, okay? Because we're not satisfied with a mere terabyte a second anymore. Okay? We're not satisfied with just big data in my drawer or on my server, but big data coming at me like a fire hose. Because who knows when that new thing will be just occur in the data set, so you've got to keep looking at the new data and not just the old. Okay, so the data growth is sort of triggered by this natural human curiosity. Okay, so let's tap into that. Okay, so I say every child is a born scientist. Let's tap into that. And this I think, I see this happens in our own courses where we're doing some changes in the way we teach even our science labs at the university, where the students traditionally will follow some canned cookbook. It's almost like a menu, right? And, do A, then do B, then do C, and they just plug in a number, and there's no mind engagement at all, right? So traditionally when we do these astronomy labs, and I've seen this happen, the students are talking about everything else but the science. They're talking about the party last weekend, the party next weekend. So we introduced live data in the class. It gave them real, true astronomical data and had them do work with it. All right, real stuff. Okay, I leave the room and step out, go to the bathroom or something. I come back to the class, and guess what the students are talking about? They're talking about galaxy evolution. Do you have a red galaxy? Wow, how did you see that? I got the blue in here. So now they're talking about the discovery. They're talking about the science because they're doing it, not just being told about it. Okay, so I think this is what big data can do for us, is that it puts information and knowledge into people's hands. And so this is why there's this enormous job opportunity in the big data field. Every business, every government agency, every science discipline, everything is finding out, every entity, every organization is finding out, hey, we got a lot of information here. We want to find out what information and knowledge is contained in it about our customers, about our business, about our bottom line, about the best decisions, about what will sell next year, and what sold best last year, and how does the weather affect it, and so on and so on. So we need people who would help us do that. Okay, so now it's this #1 priority and challenge just about everywhere. So on a typical day, you can't really read this. On a typical day, since I am active on Twitter, I can tell you, I tweet about articles that I find in the news and other things. And there's a bunch of articles here. This would be just like a single day. If you just went to Google News or some news source like that, smart cities worth $1 trillion by 2016. Such and such university adopts predictive analytics. Big data drives big IT spending, $232 billion by 2016. Big data tackles patients who don't take their meds, creating a better world, management revolution, so on and so on and so on. It's like touching everything. And that's a typical day. Okay. So what is big data? Okay, we've been hearing definitions. I like this. This is not a definition, but it's just a nice statement. So by Dan Ariely, who said big data is like teenage sex. Okay, here we go. Okay, so everyone talks about it. Nobody really knows how to do it. Everyone thinks everyone else is doing it, so everyone claims they're doing it. All right. And I think that's sort of where we've been for a while in big data. Okay? So you go to these conferences, and this is sort of like the representative statement of most of the things you hear there. Okay. But more seriously, I throw in this, which is my preferred definition now. It's just these 4 words. Big data refers to everything quantified and tracked. So you're now measuring the pulse of the world through social media, through your electronic health records or whatever. We have personalized medicine, okay, and education, which people talk a lot more about personalized education, that is looking at each individual student's performance, not just in a big test, but every individual little component of a test or homework. So as more and more stuff goes online in education, these e-learning platforms, they can now insert some kind of intervention to help students who are maybe struggling. That student gets the specific intervention they need. And when I was talking with some other people about this recently, I found out, or at least I realized, the light bulb sort of went off in my head, it's not just the poor performing student who needs the intervention. Even the gifted and talented student needs the intervention. Why? Because they're probably bored out of their mind with the content they're being presented. So gifted and talented students perform poorly in school because they're not challenged enough. Okay, so even recognizing that this student needs harder stuff to do is important. So personalized education and everywhere else. I mean, I don't have time to read through the list. I'm getting unflagged already. So I'll go over a couple minutes until you throw me off the stage. Okay, so I wanted to mention these characteristics. Okay, so we have these sort of like opinions about big data. We have these definitions that float around. We have all kinds of things. I want to mention these 4 characteristics real fast, and then I'll wrap up. And that is, one of them has to do with the volume, of course. The word big is a reference to volume. But just the magnitude of it, here's another way to think about it. Okay? So in the year 2003, folks at UC Berkeley estimated how much data had been created in the world since the beginning of human history up through the year 2002. So all the libraries, all the research laboratories, all the government agencies, everything you can think of, all the cat videos on YouTube, you name it. Okay, so the total amount of data created by the world from all of human history through 2002 was 5 exabytes, which we learned a while ago was 5 billion gigabytes, okay? 5 exabytes. In 2011, the same amount was created every 2 days, and last year, the same amount of data was created every 10 minutes. Right? So from the time I started this talk to now, that's 20 minutes, okay, the world has created twice the amount of data that the entire planet Earth had created from the beginning of human history up through the year 2002 combined. And of course, this is not only exponential in its growth, it's exponential in its growth rate. So if you understand exponentials, you know what I mean. Even the derivative of an exponential is an exponential. Okay? That is, so the growth rate is accelerating exponentially. So the same amount of data will be created every few seconds by next year. Okay, that's big data. Okay. All right. So it's everywhere. Okay, characteristic number 1, the volume. Characteristic number 2, it's everywhere. The lists we've seen already today. Characteristic 3 is the job opportunity. All right, so now everybody realizes they need this, so job opportunities are skyrocketing. So when I talk to my students, I tell them the sob stories. When I came out of grad school, there were typically 100 applicants per job. Okay, so it was really hard. Now, in data science and big data, the equation is completely flipped. These are just rules of thumb. They're not actual precise numbers, but there's hundreds of jobs, dozens of jobs per applicant. Right? And I know I get hundreds of these per day in my inbox. All right, I get 2 or 3 calls a week. I mean, this is a real thing. And part of the reason for that is, again, everybody recognizing this as the new oil, the new gold, or whatever. So some numbers. The McKinsey report, which also came out in 2012, which actually was one of the triggers for the Obama administration's National Big Data Initiative, they came out and said basically that there will be about 500,000 or 1.5 million person shortage within 5 years in this field. Okay, so these are not 1.5 million new jobs, but 1.5 million people short for the jobs that we expect. All right, so it's a real serious national challenge. Big data investments will exceed $1 trillion, and there's some examples like in healthcare alone, $500 billion. Okay. Disruptive technology. So another McKinsey report last year came out, talked about disruptive technologies, mobile internet, automation of knowledge work, Internet of Things, cloud, advanced robotics, autonomous and near-autonomous vehicles, next generation genomics, and so on. If you read the report, you realize that big data or data science or data is foundational to almost all of these disruptive technologies. And they estimate these disruptive technologies represent $33 trillion per year. That's ridiculous, right? So where are the people? We need to find the people to do this. So there's a long list of things that go back 16, 17 years. National study reports, again, you can't read that from where you're seated, but the point is National Academy of Sciences and many other agencies all the way down to number 15, which is the President's initiative. There's been a history over the last few years of more and more and more federal agencies, big, the major agencies like National Science Foundation, Department of Energy, National Science Board, National Academies, all calling for more training in this area. It's an imperative. Okay, so that leads now to my 4th characteristic, which is now this emergence in the last few years of data science or data-oriented science. So I look at this from a science perspective. It's using the data and posing questions against the data to find the answer. Okay. So 30 years ago, when I was coming out of graduate school, I did computer simulations of colliding galaxies. That was my dissertation. So I ran these numerical models, and then I did inquiry questions against the outputs of my simulations. All right. I also went to the telescope and collected experimental data, but I was creating my own computational data and testing my model. All right. Now I have a huge data set against which I can test my hypotheses. All right? So I can test a hypothesis that when people talk like this, they're about to have a social uprising. Because we had the Arab Spring, and we had the Ukraine situation, and we had this, that, and the other thing. Okay, so we have historical training sets that show us that when people talk like this or tweet like this, so we use social media data as a predictive tool, just like we can use other kinds of data as predictive tools in other disciplines. All right, so this data orientation now represents the fourth paradigm of science. So from theory and experiment to computational science to now data science. Okay, so that's my Bourne ultimatum, with apologies to anyone in the room who watches the Bourne movies. Data literacy for all. But I love this quote from H.G. Wells over 100 years ago. H.G. Wells, right, the guy who wrote The Time Machine and other science fiction things. He said, statistical thinking will one day be as necessary for efficient citizenship as the ability to read and write. Wow, that is so true today. So I teach a course on data ethics where I teach statistical thinking. In fact, I teach the opposite of it, okay, so to show my students what not to do. And I use a little book called How to Lie with Statistics. Okay, so I teach my students how to lie, and they love it. Now they know how to lie, they know how to do proper inference from data. They learn about correlation doesn't imply causation, and a lot of other things, okay? So we need to do this. All right, so when I talk about data science and big data, what I'm talking about is this ability to decode knowledge from data representation into human understanding. Okay, so I can do a genetic sequence of a person, and I have the complete DNA scan of that person, okay, which is I don't know, a few hundred gigabytes of ones and zeros, and it means nothing if I just look at it as ones and zeros. However, that data set encodes that person's life history. Now, when will they likely turn gray? Will they lose their hair? Will they lose their teeth? Will they be susceptible to Alzheimer's disease? Will they contract certain cancers? Okay, it's all there. But just looking at the ones and zeros, I don't get it. So you need the data scientist and the domain expert to decode the data, to transform it. The data already contains all the knowledge, but it's in byte format. We need to transform it to human understanding format. Okay, so as Carl Sagan, there's somewhere something incredible is waiting to be known. It's there in the data. We need the data science expertise, the people with data literacy to help us do the discovery. And in science, as I said, we see many examples in the science domain, but that's just one example. I talked about astro, bio, geoinformatics. Now we're seeing the emergence of things like urban informatics, okay, using data to make better decisions in cities, crime, transportation, energy, whatever. I mean, it's just finances. I mean, just things that you wouldn't think of as science. It is becoming science because now we can pose questions against the data set and build better models for operating cities better, or whatever it happens to be. All right, so that's the rationale for big data science for me, is that now we have, as we collect all this data, everything quantified and tracked, we now have the full data set. We can now do whole population analytics. So Dr. Bai already mentioned this earlier. We no longer have subsamples or incomplete samples. We have now a full sample of information against which we can ask questions. And we can go from the old style of business intelligence, it used to be called, from reporting what happened in the past to prediction about what will happen in the future. Okay, so from the old style, hindsight and oversight, that is understanding what my business has been doing, to insight and foresight, looking to the future. Okay, so it will help us to make this transformation from data to information to knowledge, to understanding at the end. And there's a few techniques for this, which I won't mention anymore because I'm out of time. So you can think about different ways of discovery. I will come back to this later if people have questions. So I'll just pass right past these slides here. But you can discover many different kinds of things in your data: trends, correlations, patterns, associations, even the rare one of the kind of thing I call, some people call outlier detection. I call it surprise discovery, okay, finding the rare, unexpected thing. So at the end of the day, you can think of big data being good for discovery and decision support, and my last slide just elaborates upon that a little bit more. In other contexts, I give a talk on what I call the 3 D to Ds of big data: data to discovery, data to decisions, and data to dollars. Okay, so that really leads to the big ROI. In business, we normally call that return on investment, but in big data world, I want to call that return on innovation. That is, as you innovate and change your business practice, change your education practice, change whatever you do, using the information and data that's available to you, you really are innovating and changing the world as well as changing your business. And there's going to be a huge return, a big ROI on that investment if you do that. So thank you.
I was afraid that we are going to be asked as a test, how many of you can say how many digits are in the epic byte? I don't think any one of us could remember that. And this is mind-boggling. As I was listening to the speakers, and I'm working in this space for some time now, every time the discussion comes and you start thinking more and more challenges and opportunities in this space. What I'm going to do is to take only a few minutes of your time and tell you what Bridging Nations and I personally is doing in this space. And there are two examples of sorry about that. See, those of you who know about Bridging Nations, you will say, what is this Dr. P trying to do now here all of a sudden, going back to his roots as a technologist? And I think some of you know it. My PhD is electrical engineering, not in political science. And I think as you saw in the first slide of the bridge, one of the pillars is technological innovations. And I don't believe that anything can be not solved by technology. So if you apply technology properly with a proper leadership, you can solve more or less any problem that you can find. This Career Folio is what I'm going to talk to you about. Career Folio is a company or a startup that I'm investing. And also tonight they agreed to do some, be a sponsor for our reception tonight. And I'm mentioning this for the disclosure purposes. And there is a vision behind Career Folio. If you see into the tagline, it is a careers for lifetime, prosperity for lifetime. I have been interested, and some of you know it, to set up a university. Education was my first love, and I realized after spending several years in it that really the problem that people are not spending enough time is finding jobs to the students. That means the students are not on the career path. And typically, I think all of you know how quickly you become obsolete. When I came to this country, I used punch cards, Fortran programming language. And here today now, I'm working with big data and totally new stuff. Now, when a student enters into the college, what he does is first mile of higher education. When he comes out of it, we call it as the last mile. And that last mile in higher education is the one that is the most difficult. It is not closed. And so there is a investment being made in this platform product ecosystem, what we call Career Folio. Lifetime jobs, lifetime prosperity. So the idea here, and this is a very big thing in the sense, think of it this way. In the world, there are almost 3 billion people who are looking for jobs. And one of the main things people tell us why they are not able to find, because there is no connection between the jobs and the skills of the person. And this is not just me, but everybody. So just imagine yourself, how long does it take for a person to find a job, a student to find a job? And if you do this survey, which we did informal survey, it takes on the average of 4 to 8 to 12 weeks. And imagine yourself, if the person gets and saves those 3 months of his life being employed and creating the wealth and prosperity for himself, for his family. Think of an employer, and I am one of those employers. It takes a long time to find the right people. And think of the value that the friction in the system. If you can make that happen quickly, you are going to reduce a lot of it, and there is an economic value to about this effort. So from the first job to the last job, because as you know, your jobs on the whole change 10 times in your careers. And that is a big, big number to think of. Not only that, one of the things we want to do in the career folio is try to get you the best package deal. And what happens is when people are new, it's really the e-commerce issue. Buyers and sellers. I have some skills. I'm trying to sell my skills. So we have to treat this whole student employability, higher education, from the perspective as an e-commerce institution, and how do we really reinvent it. In the December when we did this conference, our topic was what you call the higher education tsunami, winners and losers. And we'll be doing a similar concept in the December to see what happened to our research for the end of the year. So here is a total paradigm shift. Okay? Looking at education, higher education and the institution in a different way. Look at the students not as your product. I mean, think of them as your product, not as your customer. And when I talk to the professors, when I see some of you are here, they don't like it that way. Say, we are not in the business of predicting products. But when you give some serious thought to it, you will find it. That is exactly what that. Your real customer is the employer. So now let me just walk through this very architecturally. And this is fairly complex. Simplistically, it is very clear. But what is going on inside that big diagram, knowledge discovery engine and matching engine, is all of this big data, artificial intelligence, machine learning, and statistical things. All of that stuff is inside that black box. So how are we really doing it, and what are we delivering to the end customer? If I am a company, what we are delivering to you, you put your job requirement on the internet, either our portal or our platform or anywhere else. Within 5 minutes, we will send you top 10 resumes that we will guarantee you will hire one of those. I would like to know if any one of you heard anybody making such a crazy claim. And think of the power of that technology. Instantly, it's not going to be easy to do all this, as the issue that both of our speakers pointed out, to do this real-time thing. It's a very, very complex thing. And why am I doing this crazy thing? He will say, because if we can make this happen, I believe there is a quantum jump in the economic prosperity and the well-being of each of us. Employer getting the jobs immediately filled up, a great thing. Employee getting the job immediately. And that is what we are trying to do with this. And not only this has a technological challenge, it has a great social value in my opinion. That's why I'm putting, so-called, when my friends say, put your money where your mouth is, and that's what I'm doing in this, investing in this particular startup. So if you think of from the job seeker's perspective, as soon as I put my resume on the internet, we would like to submit to you 10 best companies potentially could hire you. And just think of how, those of you who have been into struggling, and I deal with a lot of young interns, plus friends, all of them, and I know you have dealt with it, ask them how hard it is to find a job. It is not just the unemployment issue, there's a lot of friction into the system. So we're hoping that the big data, algorithms, analytics, and the great platforms like IBM, we do expect to deploy IBM platform to implement some of these things. So where does the data come from this whole thing? It comes from social networks, as you heard, because that is our new culture. Everybody's putting information on this thing. The companies have their own private data, and there are lots of other places who are trying to put the information, the government agencies and all that. Huge amounts of data exist about the jobs and employability. Okay, now this is a little bit of specific product-wise, what different services we offer. And one of them on the right-hand side, I want you to think of is the Insta skills. What I believe is that if the jobs are changing, and if I have to make a transition 8 to 10 times in my career, 40, 50 years of working life, somebody has to really make sure that I'm learning the right things. And that is one of the things that we expect to resolve. And That is again is a very tough problem because everything is getting obsolete and there has to be very good predictions and there has to be almost like a relative constant complex thing. And the jobs are getting global, so many variables. It is like a functional equation with almost infinite variables, almost like you cannot solve that. But with a lot of innovation that people like our speakers are doing and their colleagues are doing, I think we can get there. Now, just to give you some example, some of our young interns, they are doing this research. Like I said to myself and my colleagues and all that, how do I really know what is it going to be required as time goes by? How can we forecast them? Okay, first thing, we have to get a very good amount of reliable data. And so in the case of skill sets, you have to have the demand and supply side. What does the industry want? And many states and agencies work around that problem. But there is no linkages made between that and what the supply side, which the institutions, like some of you who are from the education, is providing. So we need to create that bridge between the job seekers and the employer requirement. And this, I'm not the only one. Business Roundtable, they came up with a report. They did the survey of the president of universities and asked them what is most important thing for them. And they also did the same survey with the CEOs of the company. Total expectation differences. The universities are more interested in research and prestige and all that. The employers are interested with experience, internet. The internship are the number one choice when they hire people. So this is just to give you flavor of, and what you are seeing here is just fresh report that is produced this morning. Looking at the last 12 years, 30 majors coming out of colleges. Using that data, I asked, where is our friend Leo is here? I asked Leo, and he is a statistical major. Can you tell me in the next year what majors would be very good if I had to advise my son or daughter to get into college? And this is what he has found. And these are the kind, and then you will see that out of the 5, there are 3 are declining opportunities, 1 is 2 are increasing. And this should be the input to the companies and to the input to the institutions. Does that make sense? And that is why one of the slides that Rosemary used, our focus at Vision Nations, in addition to the previous focus, is what we call is the higher education triangle, partnership between academics, the government, and the employers or the industry. And that is where we are working on, and I want to one more time appreciate you all coming. And now we are going to really grill our speakers by asking them tough questions. But I don't think there's going to be any question that they cannot answer. Okay, so please go ahead, open up. We have half an hour. That's why we kept a lot of time for question answer. You took personal time to come here. I hope it is worth your visiting this. So, start. Okay. Please identify yourself. That
my name is Jeff Fogel. I'd just like to clarify Dr. Ford's information regarding the extraordinary growth in the creation of big data. In many cases, that's really the capture of data that always existed but wasn't captured. Is that correct? For example, in 2003, if I got on a metro bus to come here, I created perhaps no data. Today, with my smart card and with the video recording of my activities on the bus and so on, I assume I've generated an extraordinary number of bytes of data. Is that what that expansion's about, or am I missing the point of that?
I guess I would say it differently. The human behavior, of course, behavior changes all the time, right? But human behavior is still human behavior. And so what you did in 2003 to catch a bus and go somewhere could be essentially the same as you do today. And so now we're measuring and tracking that, which is what my big data definition is about. We're now, so your point of ingress and egress is being captured maybe by some surveillance camera, the use of your Metro card tracks when you're coming and going out of the system. Your smartphone has a GPS tracker so we know where you are. So now there's all this information that's measuring and tracking what you just did, which is get on a bus to get here. So in a sense, yes, it was all, you were always doing it, and now we're capturing it. So So I guess in that context, I would agree with you, but I wouldn't necessarily say we've always had the data, now we're capturing the data. We've always had human behavior, and now we're capturing it in the form of data.
Go ahead.
I'm a little bit confused about the way Career Folio will work, because you mentioned the kind of importation of job searching materials, but that seems to be such a small portion of the data that would be used to assess a candidate, and there would be a high level of self-reporting bias likely in things like a resume or a cover letter. So would candidates that would want to be included in such a system opt in to have other information or data bits included about them? So that could be stuff like voluntary social data to hook up their Twitter and Facebook so that employees can call like keywords and maybe be able to determine this candidate's personality, or the bus example, would they say, yeah, I'm okay with having my cell phone data GPS tracked for 2 years so they can see if I'm getting to my current job on time, or link it to your health data and see this person is very unlikely to need to take a sick day in the next 10 years. I mean, would that all come into play, and would it be voluntary opt-in?
The answer is going to be yes.
Okay.
And that is why it becomes very complex problem, very exciting problem.
Mm-hmm.
And that is why I feel it is challenging for me to spend time and money into it.
Cool.
And also because if we can solve most of these issues, like for example, our first implementation, most resumes are extremely unstructured, very incomplete. So our first exercise is to go and take their LinkedIn profile and add into the resume. And also we're going to do some automated questions and answers to the thing. And all of this is only possible that the technology allows us to do it, which we couldn't do. And as we go along the way, we'll do like you just said, maybe we will analyze the person by looking at his tweets. And so some of the interview processes could be cut short. So like for example, this Insta Campus thing that I just pointed out, we were able to find 20 students by interviewing 50 colleges and 5,000 students in 2 weeks. A lot of things were done online, a lot of things instantly, all of those things. And the big data, plus analytics techniques, plus online education, all of that digital technology is allowing us to do things better and better. Yeah.
Two questions for Professor Bond. Number one, if all the major universities in the United States decided to introduce both at the undergraduate and graduate level the discipline bioinformatics, informatics in various disciplines, do we have enough faculty to teach these, to train out enough number of graduates per year? The second question is, what is the program at George Mason? Which specific branch of informatics you give undergraduate and graduate degree?
Okay, so the first question, I think the answer is no. There's not enough. Not only are there not enough people coming out of universities or other training programs to fill these jobs, there are not enough people to teach those people. Okay, so when you watch the big data news, like I watch as part of my Twitter life, I watch what's happening and tweet about it. There are universities all over the place creating programs like this. And they're actually redeploying existing faculty, for example, computer science faculty or even bioinformatics and geoinformatics faculty, people like myself who transformed myself from being an astronomer to a data scientist. But there's just not enough faculty to do these things. And there are, in fact, not enough programs even to turn out the, not only just, again, to fill the existing jobs, but the 1.5 million person shortage that we're predicting. And your second question about our programs, we have 3 levels of programs in just my department, but there are many programs across the university, so we have depth and breadth, okay? So we have PhD, master's, and undergraduate, and my program, which is a data science degree. So it focuses more on the scientific aspect of learning from data. But if you look across the campus, there's a broad spectrum of things happening. This is true for a lot of other universities, so I don't mean to be particular about my university, but this is happening. So we have business analytics degrees, okay, so that the students who are getting an MBA, traditional MBA, can get an analytics component of that. If you look in, for example, the computer science departments, there's a lot more focus on big data computing, so teaching not just like Java programming, but Hadoop programming, which is one of the major languages for analysis of data. And there's been a lot more interest in sort of the machine learning and artificial intelligence programs in computer science departments. I also see in my school, I see a health informatics. We have a health informatics degree, so students can learn how to use like electronic medical records, electronic health records, to learn to do personalized medicine. But not only that, health informatics includes a lot more, like fraud detection. I mean, it's a $50 billion or more problem in this country that false health claims. Okay, I don't know, maybe it's even more than that number, but okay, so just fraud detection, which is applicable not just to insurance, health insurance, but in a lot of other areas like like car insurance or in other kinds of any kind of job application, like when people go to Careerfolio. Is that what it's called? I'm sorry. Yeah, you go to your website, they might put in the false information. So how do you determine that? So our education department has a certificate, graduate certificate in data-driven decision making, which is for school administrators, principals, and teachers to use student data to improve the education of individual students and schools. So I mean, I could just keep going on. I mean, it's just amazing the breadth of places this is touching. And again, we have this depth because we have the different programs from BS, MS, PhD, and graduate certificates, which are not degrees, but I mean people who want a professional certificate to improve their employment standing, to get a promotion on their job or something. They don't want to necessarily go back for a full degree, they can get a certificate. So many opportunities are popping up everywhere.
Eric Stortz with Colorado Technical University. So, on Twitter. My question would be for any of you guys on the panel. Do you see or know of any universities that you think are standouts in using big data to drive student employability? Is there anyone who comes to mind that you think of that you go, they're leading or they're progressive in how they're using their data to help drive their graduates to employment? Or is it a vast openness of opportunity?
I will answer last.
I think it's vast openness. Like, I don't think there are any universities adopting big data. Maybe they teach big data, but they use big data as much as they should. Okay, that's my impression. Okay.
Right. So if your question is about whether they use it for this purpose, yeah, I think there's very few that are doing that.
Our research has indicated that, and I had talked to very many universities, career services departments, and presidents, friends of mine, and all that. This is still not in the mainstream of their activities, and that is why I shifted my focus from focusing on creating an online university to closing this last mile. And so, if some of you are in the audience from the education field, we want to set up partnership. We are going to use IBM platform as one of our platform, and please let's work together and make this as a truly important social contribution to higher education, employability, prosperity. I have not run into, but everybody I speak to, they are familiar with some of these issues.
I did think of another answer to your question, Eric, and that is something that's astonishing to me as a grader. Our university has a survey that they ask our students to complete every semester. And this survey is a very personal survey, like what's going on in your life? How do you feel? Are you feeling depressed? How's your finances? How are your courses going? How's your family life? How are things in the dorm? Do you feel bullied in any classroom? Have you been sexually harassed? I mean, all of these really revealing personal questions, and the students want to answer these questions. I mean, I come from the day where, man, you wouldn't tell anybody anything, right? But now, the students want to share. I mean, that's one of the characteristics, I guess people call it the digital generation, right? People just want to share. Sometimes they share too much information, the TMI problem. But still, so the university it incorporates these responses in these surveys into, believe it or not, a student dashboard. All right, now I actually haven't used it, though I probably should as an advisor, but what it provides is I can go in there and log in, and it gives me basically a green, yellow, red signal for a given student. So if a student, face it, I mean, it's a really hard thing to talk about, but suicide is a major issue in the young generation as well as we see in the returning veterans. Okay, so there's a societal problem which a lot of people are being quiet about, but it's very real. And the pressures on young people today are so much larger than I have children of my own in that age group, so I can see it there too. And so they're willing to share the information, and so I actually went to a training course to learn how to use this dashboard, right? And so I asked the question, I said, gee, if I contact this student, wouldn't they be really angry with me to know this information about them and contact them? And the person who was giving the training, she was, about, like I said, a person younger than my own children, okay? So a young person, she said, oh no, absolutely not, they want you to be in their face. I said, okay, so I guess I'll get in their face then. Okay. They want people to know. So it's that sort of crying for help thing. You want people to respond to your cry. So that's one way it's being used. And it's not necessarily the career path thing and an employability thing, but it's a way that data is being collected that can be used.
Right. I think as a follow-up to his point would be that employability is a much more complex problem than solving the safety problems. Personalize the careers and personalize the courses for a student. For example, it is so easy now. So many courses are available. There should be a technology to map a student's profile into the courses he should be offered, and everything that is offered to the student should be personalized. I have not seen anybody doing that yet except on the fringes. But maybe you know it, you are in that field more active than we are.
Yeah, just to follow up the one thing, and I wonder if it would fit some of the definitions of the big data that you all put up there, which is LinkedIn is very interesting to me in that they are starting to, I think, deconstruct the traditional diploma and the traditional job, and they are now achieving greater depth of clarity on what professional skills are necessary for a given job and what professional skills would be coming from students, and then beginning to now do, I think, some of that, what had been a job seeker go look for jobs, now LinkedIn suggests jobs to you, and it'll show you what percent of the applicant pool you would be, if you'd be top 10 or bottom 50 or bottom 30, and it will reveal to you what skills you have and what skills you don't have compared to other candidates. So that is the one that's interesting to me, that has some of the volume with 300 million members, some of the variety with professional employers and students and all those types of things. So that's one that's been interesting to me. I don't know if it would fit your definitions, but what the data sets that they're doing and combining, and that concept of showing something that wasn't shown before, in terms of very specific professional skills against a very specific job at a specific company, seems very powerful.
It will fit the definition of big data.
I pose this question to the whole panel, but is there any fear that increasing reliance on big data is going to diminish personal autonomy and accountability?
Yeah, I can maybe address that first. A big issue with big data is privacy, right, and security. So, talk about universities. I have been involved in some discussions with some of the universities. I think one thing they are not certain about is what data can they share. Okay, what data can they allow access to vendors or source, right? Because they don't have all the tools. They have to utilize tools provided by third-party vendors. But they are not quite sure, right? So the rules are not there yet, okay? The laws are not there yet. So privacy is a big issue. So there are products, technology there to help them navigate this part of the world. But that's a big issue why some companies or some universities are hesitant, okay, to deploy big data, quote unquote, on the large scale, because they are not sure what to do this thing, right? They may be sued for maybe allowing access to certain data they cannot do. They are not supposed to do. Okay.
I guess when I hear your question, I think of this line in the movie Jurassic Park. If you remember the movie at all. And so the scientists are brought in to sort of validate this crazy idea of having dinosaurs in a park. And Dr. Malcolm says, you're so busy wondering whether you could, you never asked whether you should. And I think in the area of big data, we see so many uses of big data by businesses, and we hear about Target how they determined that the girl was pregnant and sent the coupons to the home, and of course the father discovered his daughter was pregnant before she even told him. And so I think there's a lack of shared accountability for shared data. So a lot of businesses are now sharing your data, and we get these data privacy statements from our credit card companies and our banks and everything. And I just got one yesterday in the mail. And I tell you what I do. I glance at it and I put it in the trash. I mean, it's like 5 pages of fine print. And I'm sure it was written by a lawyer, so it's not, whatever it says there is probably not meaningful, right? Because it's basically, it's CYA for the business, right? It's not CYA for me. So there needs to be shared accountability, right? It's not just, that if I do something, I'm responsible, but hey, shouldn't the users of this data also be held accountable if something bad happens to me, like identity theft or something like that? So I think there's a real lack of that question like I said, we're too busy realizing we can do all this cool stuff with data, but really, should we?
Right. It just seems like a slippery slope. For example, if somebody, with big data told me that I, have a 98% chance of developing lung cancer despite anything else, I would either say, okay, I'm just gonna smoke anyway.
Oh, yeah, snakes, right?
Or, it's just, people could kind of lose their own kind of accountability for themselves, I think. Or like for a student, with this career folio, instead of them kind of saying, having that experience of casting the net out into the job market and actually kind of discovering for themselves, like, this career works for me, this kind of boss works for me, this kind of work environment works for me, we'd kind of be taking that away from them, right? And just essentially be telling them. And it would kind of, again, to me, take away a little bit of that kind of self-discovery and accountability that, helps us develop as individuals. Was that like a little bit too philosophical? Everyone's kind of looking at me like I'm nuts.
No.
Okay.
It's thought-provoking. It's not nuts.
One thought I threw out there is sometimes they've talked about selecting a college or selecting a job is sometimes one of the most, the darkest things you have to search for. You have the least amount of information. They've compared it to marriage and joked about how does that work for about half the population. So more information might get them to a better choice sooner than a lot of wrong left turns, right turns.
It could, but I think there's also like value in failure. And would we, with enough data, would we be eliminating failure? And like, how would that affect people like psychologically if like, they were told, oh, you're a 99% match for this job, and then they got like fired or whatever. It's just it's interesting to think about.
It's a little bit the risk with the big data. The risk is to labelize the people, because once you put the data information into the database, that stays forever. And sometimes it's very difficult to change anything, but particularly people, human, is evaluating, is growing, constantly is changing. When you will sample Bill Gates drop out, if he were in the database and based on his record, academic college record, he would never get any job, any contract. But look what happened because we didn't have, or he didn't, he wasn't at the time when those numbers, zeros and ones, decide about the human life. And I think we should be very careful also in this, because number one, to create a big database, you have to have very precise and standardized database collection and procedures, because once you put a similar word, even in resume for the applicant for the job, he meant the same, but use slightly different phrase that is in the job description, and the algorithm of this human resources system will not pick up his resume, and will be lost forever. So that, and also in the big database decision like government, national, we losing the connection. Actually, we allow the machineries and database to give us the ready food to accept and choose from a very few options. Because if there's any algorithm that searches this huge database and has some glitch or some not very well design or architecture of the system, it has an imperfection. They will grab and collect false information, and based on those database, will bring to the decision maker very false options, and they will say, as we had with in a few years, that they have this, not, and we have to go there. Right. So that's a little bit. We have to put a little bit more personal and maybe very traditional, as we had this intelligence analysis. They were looking for information, but with a human feeling, not just rely on the computer. Computer is very black and white.
That's
Zero,
right.
one,
I think what you're
zero,
saying is we need to
Yeah.
keep the human in the loop, which is right. We can't just let the machines run the.
But the beginning is no. But the beginning is with the. Before we collect, because right now we collect and we make this database chaotic. Basically, everything whoever is delivered, we store in database. But if we put this a little bit gate into and rectify this. If this matches absolutely this is format,
Yeah, I think,
yes, this is true database.
see, Jan, your point is quite right in the sense, but leaving aside the human aspect of it, we at least agree that the machines will do 10 times or 100 times better job.
It's faster.
Faster than also the complexity of the job, you know. Like if, like he says in the NASA and the weather and all of those things, it's impossible for anybody. So the 2 points you raise, you know, Jan, by the way, is an energy expert and he has worked with me in the past and in terms of the energy education. See, the issue of privacy, protection, etc., I believe there are sufficient laws in most countries to protect that. Whether it is a small data of, let's say, LexisNexis, or for that matter, if you Google it, people tell me within Google, within 5 minutes, I can find anything I want to know about you. So those issues the society has to solve by legislation and code of conduct and all those things. It's the only way. I don't see anything else. We have probably one more last question, since we will then continue upstairs and interact with each other. Any other last question?
Can I give a response also?
Please go ahead. Yeah.
There's no question. So I was thinking of this young lady, a question about the sort of the machine telling you what your job should be and that kind of thing, and what if it doesn't work. And so this is why I was saying that you need the human in the loop, even for the comments that were made earlier, that you need the person. And it's like the example I gave in our university. We're collecting all this data from these students about how they feel about things and what's going on in their education and their academic and their social and their dorm life, etc. But there's no human analyzing this mountain of data from 35,000 students. The machine, creates a dashboard which gives, a warning to me that a student might be at risk. Okay, the machine doesn't do something to the student. I still have to get engaged. I still personally have to do something. So the example I use in my classes that illustrate this, so not specifically the student question, but it's very similar to your question, and that's the idea of using models to determine whether someone is a terrorist at an airport. All right, so this is the exact example I gave when I visited the executive office of the president right after 9/11. Okay, so I said, so as a scientist, I build models, right? So there's inputs that yield outputs. Okay, so in the case of ascertaining whether a person who's going through the security line at the airport is a person who I should pay attention to if I'm a security person, security officer. I build a model for this, right? So you know all about these models. There was one model which says, okay, there was a shoe bomber back in 2003 or whatever. So now we all take our shoes off at the airport, right? Because bombs are going to be in shoes. All right. Well, what's the likelihood there's going to be a bomb in a shoe now that everybody is taking their shoes off? Probably isn't going to happen. But that's a model of a terrorist. They put a bomb in their shoe. So now we all have to take our shoes off when we go to the line. Okay. So if you build a model. And then apply that model to each person who comes through the security line, you come up with the following scenario. Okay, so we look at the 9/11 terrorists and we see these people were of Arabic origin. They all traveled together. They spent time together in Hamburg, Germany. There was about 20 of them. They exchanged lots of phone calls together. They had lots of connections. They traveled with the same credit card. They spend, they had one-way tickets to places and stayed there a long time together, just like that morning. They all had one-way tickets to the West Coast on the same credit card, but none of them had return tickets. They were planning to return. So if you build a model using all those characteristics, same credit card, time together, and Hamburg, Germany, and their Arabic origin, about 20 of them. If you build that model and then apply that model, the next time you see that characteristic group boarding an airplane somewhere, you'll go out and arrest the Libyan World Cup soccer team. All right, because it satisfies all those characteristics, all right? So what you need to do is you need to say, this is just information to me, information, it's not the decision. All right, and I'm hoping that a thing like career portfolio is used as information, not a declaration that if you don't take this job, you're a failure. Now, again, I appreciate the way you've expressed it, though, and that is, it can come across too, sort of authoritarian. That is, these are the 10 jobs you should pick, and there is nothing else you can do with your life. Well, okay, so hopefully it's not going to be presented that way, but there's a fear that a lot of big data decision making either gets built or advertised that way, or really is that way. That is, businesses, since they don't have too many data scientists to hire,
they
just use the technology to spit out an answer, go out and arrest these 20 people because they have all the characteristics of 9/11 terrorists. And of course, we have to say, wait a minute, no, they're not terrorists, they're just normal people.
And this debate about technology having morality and the values, technology doesn't have any of it. It's all us, the humans, have to decide what we want to use the technology. When the birth control pills came out, which was a revolutionary thing in the woman's life, the same debate went down. Should they use, should they not use? So I think the issues you raise are very thing, and interestingly, both speakers pointed out that the big challenge is the security, privacy, and all of those in this big data. And how to humanize, certainly we all have to keep that in mind. And on this happy note, let's go and celebrate upstairs. The suite 715, and just take the elevator and go upstairs. And thank you for coming. This is fantastic. This is great.
Thank you. So I'm looking at a lot more of this Marshall Foundation.
Oh, thank you. Thank you.
That's this conference in San Diego. IBM had a really big display. And I spent last week attending a big day with several ideas.
You realize that George Mason has this program already.
Well, we were way ahead of our time.
Where has occurred?
Hello.
Yes, so much. Actually, I came here because I was following the
You're an opinion leader.
Well, I work at GW University.
Okay.
I'm there international for trying to operate like a system. So I'm trying to track now. I'm not a big data expert at all, but I'm trying to track kind of employment issues as relates to students coming in from China over here. Their return investments for students. Chinese students are students be complete full-paying students. So universities in the U.S. are really attractive. Now there's a big fight for, the quest for the best students.
I just want to understand with you, where do you project the timeline for the formation of this
So there's this
project?
whole thing about, trying to understand exactly what you're saying
in the most recent discussion of those on the
as we adapt to federal career service, how do you know, I'm sure we do great analysis of what are here.
You're doing that on a by university basis. I mean,
Well, I'm thinking for GW.
I mean, you're wondering what they're saying about GW specifically.
Right, but I think it applies to all universities actually.
Right, but your interest is obviously your own specific case, right? Not just a sort of general statement about U.S. universities.
I'm always interested in one. I'm very interested in GW, but I'm also always interested in the macro. So I just wonder, you know, I have a friend who does data analytics in the government. He, I think that's Twitter from some projects. I wonder,